The Pearson correlation coefficient R measures the strength and directions of the linear relationship between two variables. It is defined as this. X and yi are the individual sample points for variable x and y. X bar and y bar are the means of x and y. N is the number of data points. And this equation tells you how strongly two variables are related. A value close to +1 means a strong positive correlationship. Close to -1 means a strong negative correlationship. And close to 0 means no correlationship. So +1 positive, -1 negative, and 0 no correlationship. So when working with a correlation matrix, the Pearson correlation coefficient is computed pairwise for all variables. For example, if you have 10 variables, you need to use the CORR functions, MATLAB's core functions, and it will give you each entry, Cij, represent the Pearson correlation between the I and j's variables. So another thing, if you remember, we have these two terms. The denominator, this part, is the product of the standard deviation of x and y. So remember, if you have the standard deviation of x and y, you can just directly put it in the denominator. And in the numerator, computes the covariance between x and y. Okay, let us first show how this system works. So I will load the data, double click here. The first 10 columns are the x1 to x10, and the last column is output or target. So let us separate the features, I mean the x1 to x10, which means features, and the output, which is y. And then combine them again. And now I use the I will compute the Pearson correlation matrix with core functions, and it will give you this matrix. As I said, +1 means completely linear, 0 means no relationship, and -1 is negative correlationship. So labels. Let us create labels for our axis. What is this? From x1 to x10. And we will open a figure here. So we create, remember here, we create axis labels dynamically based on the number of features in x and y actually, as a label for target variables. Y is the target variables. Then we create the heat map using MATLAB's heat map functions, customizing the color map to jet for better visualizations. And the color scale ranges from -1 red, -1 is red, to 1, which is blue, making it easy to spot which variables have strong correlations. So we adjust the font size of the heat map for readability. The title is added using the annotation function, as MATLAB's heat map doesn't support direct title size modification. And we place the title in the center at the top and use the bold font for emphasis. So to ensure that the heat map fills the entire screen, we query the screen size and set the figure window accordingly. Finally, we save the heat map, use the heat map as a PNG image. Let us run this program now.